dive right into this, right? So, first one. So, 3 fractions right here. We want to convert these to decimals, okay? Been doing this since like 6th grade. All right, so 1a, find the decimal for -7 over 8. Any ideas how I might do this? Any ideas how I might do this? Right, we could punch in our calculator, right? We could do that. Or we could just do it by hand, which is what you're supposed to do, right? I don't need to teach you how to like press 4 buttons on your calculator. So we're gonna do, right? So we know the answer is gonna be negative, right? So I'm not gonna include that in my long division, because that'd be kind of confusing. So I'm gonna do 7 divided by 8, right? That's what the fraction symbol means. Okay. So, okay, 8 does not go into 7, right? Right? So I'm gonna put a 7.0 right there. I'm gonna put a 0.0 right there. Right? 8 goes into 70, right? How we doing? You gonna pass? Good. Ben Branson. Change you to excused order. So 8 goes into 70 8 times, right? 8 times 8 is 64. So I'm going to put an 8 right above that 0. 8 times 8 is 64. And I do a little bit of subtraction. I get a 6, right? Right, so my remainder is not 0, so I'm going to add another 0 to drop down. This is going to drop down here. Right? That's going to happen, right? I didn't change the value of this number. I just keep adding trailing zeros. 8 goes into 60, how many times? 7, yep. 7 times. 7 times 8 is 56. Right, keep doing it. It's an algorithm. I just keep repeating this. That's 4. 4 is also not equal to 0. So I'm going to add another trailing 0. Drop her down. All right. 8 goes into 40. How many times? 5 times. 5 times 8 is 40. 40 minus 40 is 0. No remainder. Great. So I got 875. Uh-oh, that doesn't sound right. No. Oh, yeah, so sorry. You're good. Just take this one. Yep, gotta bring that. Should have brought this decimal up, right? 0.875 is my final answer. All right. Any questions? Confusing anyone? And again, hopefully this is a review.
Oh yeah.
All right. Number B. Number B. Oh, you're right. I forgot the negative. Awesome. I forgot the negative. Don't be like me. Okay. Great job. Yeah. So a lot of students struggle with math for 2 reasons. 1, they don't know how to do it. Or 2, they do know how to do it, they just don't check their work. So always check your work, okay? If I did that on a quiz, I'm the teacher, I would have gotten that wrong because I didn't check my work. Okay. All right, so same thing over here. We want to convert 13 over 5 to a decimal, right? So I'm going to do 13 divided by 5 and do some long division. Okay, 5 is for the 13. How many times? 2. Wow. 2 times, all right? 2 times 5 is 10. All right, do my subtraction. 13 minus 10 is 3. Okay, 5 does not go into 3. 3 is not equal to 0, so I'm going to put a decimal point. I'm going to bring it up here, right? Decimal here, bring it up here. All right, add a 0, drop down to 0. 5 is in the 36 times. So I'm going to write a 6 up here. 6 times 5 is 30. 30 minus 30 is equal to 0. So no remainder, 2.6. Final answer, right? Let's check. Okay, my original fraction is positive. Final decimal should be positive. Any questions on that one? Any questions? Good, good, good. Okay. Should hopefully be review. 11 over 9. Fun, fun, fun. So 11 divided by 9, we do some long division. 9 goes into 11 how many times? 1. 1 time. Right, 1 times 9 is 9. 11 minus 9 is 2. All right, my remainder is not equal to 0, so I'm going to put a decimal place here. Right, put a 0, bring my decimal up. Well, okay. 0 drops down. 9 goes into 20 2 times. 2 times 9 is 18. 2. Uh-oh, anyone see a pattern starting to form? Yeah, it's just going to keep going. Going to keep getting 2s, on and on and on, all right? Notation for this, 1.2 with a bar over it. Okay, 1.2 repeating, 1.2 with a bar over it. Okay? That sound all right to everyone? All right. Okay, so let's go down to the second section there. Second section, 2A, graph on a number line. X is greater than or equal to -2. Okay, any idea how to do this? Yep.
Well, you do the line and you have to put the arrows on each side.
Yeah. So first so Silas is saying I first got to draw my number line, okay? Then what do you think? He said put like a dot with -2 or something?
Well, yeah, I mean, you have to like do the, are you going to make this like?
It's not going to be super detailed.
Okay, so just do a bar.
Yeah, so I'm just going to put a -2 right here, right? And am I going to be greater or less than -2? Right, so x is greater than -2, and on the real number line, we just go to the right. Right?
Wouldn't you fill it in too?
Yes. I laid a trap for you guys, so I'm going to. And this, if it's a greater than or equal to, if it's greater than or equal to, it should be a solid dot. It should be a solid dot. Right? Right, the way I remember this is if like there's more lines, right? There's more lines, you have to do an extra line if you do greater than or equal to. So you have to do like a little extra filling in. That's a little mnemonic device for you. Right. Self-explanatory, hopefully. Any questions? Anyone confused? Anyone lost? It's okay if you're lost. X is greater than 5, but it is also less than or equal to 6. All right, so we're going to draw our number line. Right? What are my 2 points I need to plot? 5 and 6, right? 5, am I going to do hollow circle or a solid dot? Hollow circle, yep. So there's my 5. What about my 6, solid or hollow? Solid, good job. Okay. All right, and x, let's think about this. X is greater than 5 and less than or equal to 6. So where am I going to shade? In between, yep. Got it. Greater than 5, right? But it's also less than or equal to 6. So all the numbers here, every possible real number between 5 and 6 satisfies that inequality. Good job. Any questions? Any questions? All right. And then Oh, switching up the notation on you. We have negative infinity 5. Any idea? So I gotta draw my number line, right? I gotta draw my number line. Right? What point should I plot on here? 5, yep. Solid or hollow? Said hollow. There we go, Silas. Hey, round of applause for Silas. All right, yeah, learning of hollow. Yeah. So this parenthesis, this is called interval notation, right? So this is saying, this is the same thing as saying negative infinity is less than x, which is less than 5. I shouldn't. This is technically, don't tell your mathematician. If you know a mathematician, don't tell them I wrote this. Technically, it's just x is less than 5 because like every number is greater than negative infinity. But yeah, so if there's parentheses, it means like it's just a regular less than or greater than sign, so it's a hollow circle. Once you get into the brackets, that's when you get into like less than or equal to, greater than or equal to. So where am I going to shade? To the left, yep, right. All the way to negative infinity. Right? All the way to negative infinity. Good. Okay. Sounds like we have a decent grasp of this. But if we don't, that's okay. You can ask me some questions. All right, D. -2, 3. All right, so I'm going to draw my real number line. All right, tell me what I should do. Fill in the circle at -2. Okay, good, good. And then what do I do at 3? Hollow, yeah, hollow. Good job, good job. All right, where do I fill in? Yeah, good job. Sweet, awesome. Flying through this. And then we just did D, so let's go to E. 7 to infinity. 7 to infinity. Draw my number line. All right. What am I gonna plot? 7 with solid or hollow? Solid. Good job. And then which side do I shade on? Right. Yeah, it's got to be greater than 7. 7 to infinity. 7 to infinity. All right. F. -3. Draw my number line. All right. Where am I going to plot? Hollows or solid? Solid. Hollow, yep, right. Because parenthesis means exclusive, so like we're not including -3 to 3. That should be a hollow circle, right? And then right in between them, I'm going to shade. All right, anyone have any questions about this section? Questions? All right. So, section 3, that third topic. I'm going to write these as inequalities. Okay, so I'm right-handed, so I know I'm blocking your view. If anyone can't see the board, please inform me. All right, right as an inequality. Parenthesis 5 to 7 square bracket. Anyone have any idea? 5 is less than x, yeah. So x is between 5 and 7, right? X is between 5 and 7, right? And then, oh my goodness. Right, and then which one of these should get an equal to line? 7, right? Yeah. So 7 square bracket means less than or equal to. Round parenthesis means just a less than. Just a less than. Is that confusing anyone? Is that confusing? If it's confusing, it's okay. All right, infinity to +3. All right. What's this one? Yeah. Yeah, so infinity is less than x, right? And then less than or equal to 3? Less than or equal to 3, yep. So this is technically, we never, so this would just be, it would actually just be, that's terrible handwriting, let me do that. There we go. Yeah, so we never write like x is greater than infinity or like less than infinity. We don't use, we just would have that. Is that confusing anyone? Why it would just be that? Because this is kind of redundant, yeah.
So why would infinity be less than
what I'm trying to say is like we wouldn't write that. We wouldn't include that part. We would only have x is less than or equal to 3.
So it's not the right answer?
This is the right answer.
So okay, so we finish that blank.
Yeah.
This is the quiz, we don't write.
Yeah, don't write that. Yeah, don't write the infinity.
So like if an infinity is less than something, you just don't put it anywhere.
Yeah, when you're doing interval notation, you would say, okay, we want every single number. This should be a negative infinity. I'm so sorry.
Oh,
Yeah.
okay.
That's a typo. There's a typo on the notes. That infinity should be a negative infinity. Okay, I see why you guys confused. Yeah, every single number is greater than negative infinity. So infinity is not technically a number. You don't need to write this down. This is like abstract math stuff. Infinity is not a number, so you can't really like use it with these symbols. Don't write like infinity is greater than or less than something. It just be x is less than or equal to 3, right? Because that's redundant. It goes all the way to negative. Like, yeah. Is that confusing? Real good. Okay, cool. And then, ooh, okay. Okay, so problem 3, part C. All right, we get a little number line, 6 and 9, and then the middle part's shaded. All right, so how would we write that? Nice, yep. So if I pull an x out of this little interval here, it's going to be greater than or equal to 6, right? Because we've got a solid dot, and less than or equal to 9, so we've got a solid dot there. So here's my answer. Confused, we confused. Going too fast, am I going too fast? 4. Write as an interval, x is greater than 6. Okay, this will touch upon what we just talked about. So x is greater than 6. What might our interval be? Yeah, I'm sorry, that's poor handwriting. If you can't read my handwriting, please tell me.
Is that interval?
Yeah, yep.
Okay.
Or the square brackets, right? In this case, it'd be parentheses.
So it's infinity in the x and 6 in the y.
So x starts at 6, right? It's greater than 6. So if you look at a number line,
Oh yeah, it's 6 in common.
if you look at a number line, it goes from 6 to infinity, right? And am I using parentheses? How do I know I'm using parentheses for both? Yeah, so it's just, there's no equal to, so they should both be parentheses. One thing I want to note, if you include infinity or negative infinity in interval notation like this, it always gets a parenthesis. It always gets a parenthesis. Because no number could ever be equal to infinity. Because infinity is not a number. It's just like a concept. So, don't worry about that too much. But yeah, just know that infinity always gets around parentheses. It always gets around parentheses. All right. Confusing. Am I good to move on? If I'm not good to move on, that's okay. All right. 4. B. We got 5. Is less than x, which is less than or equal to 10. Right, it's an interval. Okay, so yeah, I think Ben's onto something. Ben's onto something. All right, so Michael, how are you feeling about this? What about this? What do you think I might do? Okay, what do I do? Then tell me. Parentheses, okay? 5. Nice. Nice. Good job. Hey, round of applause. Mike. Good job. All right. So yeah, if you're confused by this, if you have trouble going from here to here, I think one trick might be to just draw a number line and do it on a number line. So 5 x is get a hollow line at 5, a solid circle at 10, and then it's in between them. Just for people who are struggling, if you're struggling, and then I think it's a little easier to go from here to here to here, rather than straight from here to here. All right, we okay with that? Confused? We lost? Okay, good. And then 4C, I need to get another eraser. C. X is less than or equal to -7. All right. What do you think? What you thinking?
I don't know.
Okay. So let's draw a number line, okay?
It'd be like infinity.
Negative infinity, right?
Negative infinity. And then -7.
-7, right?
-7.
Yeah. Make sure we check our work.
Bracket.
Parentheses, square brackets,
Yeah.
what am I doing?
Bracket on the right.
Bracket on the right, yeah, because I got a less than or equal to.
And parentheses on the
Yeah,
right.
negative infinity always gets a parenthesis. Okay. We good with that? Anyone confused? We got until 10:40. Okay, good. Plenty of time. Google's of time. All right, number 5. 5, part A. Rewrite using the distributive property. All right, does anyone remember what the distributive property is? Yeah, it's like this. Yeah. So, distributive property, right? A times C plus D equals AC plus AD. Right, that's the distributive property right there. This is a rule you can use. So I'm giving you this tool in your toolkit on exams, quiz, tests. This is one of the things you can use. Distributive. The real numbers are distributive of a multiplication. This is the distributive property. All right. So this first example right here is m times the quantity n squared minus q. All right. So is it Reese? You said. What's this going to be equal to?
Mn squared.
Yeah, so I'm just good. Mn squared minus n cubed. Right, so I'm going to take m, I'm going to multiply it by n squared. That's going to be my first term over here. I'm going to take m, I'm going to multiply it by minus q. That'll be my first term over here. Okay. What if it were? Let's redo this. I want to hammer something home real quick. What if it were? It's one thing I always kind of struggled with this is if there was like a minus m, like what I did, you know. So I'm going to take the minus m, multiply with my n squared, right? Negative m n squared, good. And then yeah, right. So it's going to be minus m times minus q, right? And a negative times a negative is a positive. That's going to be plus mq. All right. Then over here, we've got 3x squared y minus 6x y cubed. Okay. Rewrite using the distributive property, right? So that one, we went from on this distributive property line right here. We went left to right, right? But you don't have to do left to right. You can go right to left as well, which is what we need to do here. So what am I going to pull out? What am I going to grab? So I'm thinking the 3, right? So, right, whenever we're doing this is a factoring problem. We look at the coefficient number right here, the number that's next to my variables, and I look at the greatest common factor they have, right? Which here is 3, right? So I always pull out the greatest common factor of these two numbers, so it's going to be a 3. And then I pull out, I don't want to say this, I pull out whichever variable has the lower degree. So this has an x squared, and this has an x. So what do I pull out? An x, yeah, pull out an x. All right. And then I pull out a y or a y cubed? I take the lower one, yep, y. And then 3xy times x equals my original first term over here, so I'm going to have an x right here. Okay. And then 3xy times 2y squared is equal to my original second term over minus 2y squared. Right, is that correct? Is that correct? Yeah. So that's going to be my answer. And guys, on a quiz or a test, you can always check. You can always check your answer by distributing. You can always go backwards. So if I go backwards, I get 3x squared y minus 6 x y cubed, which is my original problem. So I can be 100% sure that I got that problem correct. All right? So does that make sense? Anyone confused? Anyone lost? All right, cool. Name the property shown. Just gonna check. See how. Check something real quick. that makes sense. Okay, so name the property shown. Six times 1 equals 6. Anyone have any idea what my properties are named? What's that? Hey, you actually got the first word right. So this is multiplicative identity property. If you write like mult identity, I'll take that. I'll take that. All right. Identity, right? 1 is called the identity element. Okay, so that means that if we multiply any number by 1, we just get that number back. All right, that's what that means. And it's multiplicative because it's a multiplication. Anyone know what the addition identity number is? If you add a number, yeah. So if you add it to a number, you just get the original number back. 0. Yep. Yep. All right. So then this next one, x times yz equals xy times z. Anyone know what that's called? Not quite. Right. So this is called the associative. Did I skip one?
Yes.
I did skip one. All right. It's going to be confusing for people. I'm going to write this. Sorry, guys. X times. I love that property so much. I just skipped right to it. All right. So here's what I did. I just switched yz to zy. You guys remember what that's called? My commutative property. Commutative. 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 Commutative property, right? That means, right, 2 plus 3 equals 3 plus 2. 2 times 3 equals 3 times 2, right? Right. It's a commutative property of real numbers under multiplication or addition. C. Now we have x times yz equals xy times z. Anyone know what this one's called? There you go. Got these, round of applause for Ben. I heard Ben say, but I think everyone else did. All right. So yeah, so it's called the associative, and one way to remember this is right. I'm just moving my parentheses around, right? Just moving them around. I'm associating the different numbers with each other in the parentheses. That's like one way to remember it. All right. And come over here. Take D. M plus 0 equals M. I touched upon this earlier. There we go, right? Additive identity. I have a 0. If I add 0 to anything, I just get that number back. Are you okay, Colleen? Is that confusing? Okay. Additive identity. I'll just do add identity. I will accept that. Additive identity property. You take a number, you add 0 to it, you get that number back. 3 times 1/3 equals 1. Anyone have an idea? Yeah. So every real number, every number has another number, real number that I can multiply by and get 1, right? 1's that identity number, and that's called its inverse. So this is multiplicative inverse. Okay, don't use our Lord's name in vain, please. All right, mult inverse. All right, multiplicative inverse. Fancy word, scary word. It just means that if I give you a real number, does someone give me a real number? 5. I heard 5 first, right? There's a number that I can multiply it by to get 1. And that, in this case, that's a horrible. Oh my gosh. It's multiplication sign. 5 times question mark equals 1. In this case, that question mark is 1/5. Anything you can think of, any real number, it's going to have that. I guarantee it. F, here's one. Here's a little strawberry to lob you. Here's a little AB equals BA. What is that? What is that, Michael? You know? Okay, look at B. Yeah, commutative, right? That just means A times B equals B times A. Just flip them around, right? Does that make any sense? You confused? Okay, you're good. Okay. That's commutative. Okay. Am I going too fast? We're good? F, and then G and H. We have a G and H. For which one? Oh, G is close. Like you're on the right track. It's additive inverse. So is that there's going to be? Yeah. So if I told you, so 7 plus -7 equals 0, right? So right, the additive identity is 0. So if I said, okay, 7 plus 0 equals 7, right? Take 7, we add 0 to it, we get that same number back, right? This is saying, hey, look, there's a number that exists such that when we add 7 to it, we get that identity element, right? Here, 7 is on the right side of the equal sign. Here, 0 is on the right side of the equal sign. So, right, what did we say about multiplicative inverse? There's a number, right? 3 times this inverse, multiplicative inverse, gets us our identity element under multiplication. Over here, this is the same thing, but for addition. Additive inverse. For any number, there's a number that I can add to it to get my addition identity element, right? So this is add inverse. Is that confusing? Yeah, so someone give me a real number, please.
2.
I heard 6. All right, so 6, there's a number I can add to 6 to get 0. And that number is -6. All right. So then we have H. We have H. All right. All right, 3 plus 4 plus 5 equals 3 plus 4 plus 5. Associative. Associative. Is that confusing anyone? Yeah, so if I move the parentheses around, if you just move the parentheses around, that's associative. I'm just going to write ASOC. Associative property, all right? How are we feeling with this stuff? Yeah. Are we scared? Are we scared? Are we afraid?
Yeah.
All right, let's do a little bit of algebra review. All right, 3 over x squared, quantity cubed. Quantity cubed, yep. So right here, gotta remember my exponent rules. Okay. So this kind of gets distributed. It's not, yeah, okay, it gets distributed. It becomes 3 cubed over x squared cubed, right? Which becomes 27 over x squared cubed. What does that become? Yeah, so when I have 2 exponents, one's in parentheses, one's outside, I multiply them together. So we get 27 over x to the 6th. 27 over x to the 6th. Okay. B 5x over 2y all to the negative 2 is equal to, what would I like to do first here? Well, I don't like, who likes negative exponents? I don't like negative exponents. How can I make that positive right from the beginning? Flip it, yep, just gonna flip it. So 2y over 5x. Now it's going to be squared, right? Now, as Silas was saying earlier, I can distribute it, right? So it becomes a 2 squared, a y squared, and then on the bottom a 5 squared, and an x squared. 4y squared over 25 x squared. Is that confusing to anyone? Is that confusing? It should be review. This is like algebra 1, algebra 2 review. So, all right. Ooh, here's one. 5x squared y over 6x cubed y squared times 3x y to the 5th over x to the 4th y cubed. All right. India's not going to cross. We're not solving for anything. We're not going to cross multiply. We're just going to simplify. What's that? Yeah, we're just going to combine, right? So this is going to become 5x squared y times 3x y to the 5th over 6x cubed y squared times x to the 4th y cubed. What do we do with my exponents when like I do like x squared or y times y to the 5th? What happens? We add. Someone say we add them?
Yeah.
Thank you. Okay, yeah, we just add them. We just add the exponents. So 5 times 3 is 15. And then I have x squared and x to the 1, so that becomes x cubed. And then I have a y and y to the 5th, so that becomes y to the 6th. And I have bottom, I have 6. X cubed, x to the 4th, so that becomes x to the 7th. Right? Y squared, y cubed becomes y to the 5th. Okay? Am I simplified all the way? Not quite, right? What do I have to do? A 5 over 2. Oh, yeah. So I want to simplify my numbers here, but I can also simplify my variables, so good job. Good job catching that. So 15 over 6 simplifies to, 5 over 2 you said? 5, and then I'm going to leave some space over 2, and then, yeah, so whichever one's bigger, whichever one, there's an x cubed on the bottom, x to the 7th, or x cubed on the top, x 7th on the bottom. That becomes x to the 4th on the bottom, and then a y on the top. Is that confusing to anyone? Are we lost? We lost? Good. Alright, good. Okay. D. Oh, here's a good one. 3x to the 5th, y to the negative 4, z to the 8th, 6x to the negative 3, y to the 5th, z squared. All right, what do I get rid of first? Like this is my personal preference. What do I like to get rid of first? I hate negative exponents. I hate negative exponents. So I'm going to flip them around. Y to the 4, negative 4 goes to the bottom, becomes y to the positive 4. 6x to the negative 3 goes to the top, becomes 6x to the positive 3. So I'm going to get 5 x to the 5th, x cubed, z to the 8th, over 6, y to the 4th, y to the 5th, z squared. All right, what do I do with these exponents here? What's that? Wait, oh, I'm so sorry. That's so confusing. That is completely my bad. Sorry. Thank you for your correction. This x to the 5 and x to the 3 just comes to x to the 8th. And y to the 4, y to the 5 becomes a y to the 9. Last thing I have to do is what? Simplify, yeah, what do I simplify?
You do the 1/2.
So I can do 1/2, that's one thing I gotta do.
And then you do your z's.
Yeah.
Z's.
Yeah, so I should have an x to the 8th, and then this z squared
Yeah. it's
takes
Z6.
away 2 away from here, so that's z 6 over 2 y to the 9. Alright, so when I'm fully simplified, my numbers are in the simplest forms in terms of a fraction. Okay. I don't have any negative exponents, and I only have each variable, either the numerator or the denominator. It's not going to be. That's one thing we're looking for on the quiz. All right. E. Actually, I'm going to skip E because I want to make sure you guys can do the homework. Before we begin. So go straight to A. 8A. Write in scientific notation. 42,000. We're going to write that in scientific notation. Anyone have any idea? All right, so scientific notation means I write it as some decimal between 0 and 10 times 10 to a power. So I want to take this, and I want to get it, so my decimal's here, right? And I move it over until I just have one digit. Right, so I'm going to move it 1, 2, 3, 4. Right, so I'm going to write 4.2. Right, and then to get the original number back, I'm going to write this, I'm going to write a dot. To get the original number back, I got to move the decimal point over 4 times, right? So to move decimal points to the right, I use positive exponents. So 4.2 times 10 to the 4. Is that confusing anyone? Okay. B, 0.00016, okay? So I'm going to move my decimal point over till I have just one non-zero digit in front of it, okay? So I'm going to move it over to the right 1, 2, 3, 4 times, right? It's going to be equal to 1.6 times 10 to the, and then to get the original number back, I got to move it to the left 4 times. To move decimal points to the left, I do a negative exponent here. It's negative 4. Is that confusing to anyone? Not confusing. Okay, good. Ooh, here's a fun one. C, 3.6 times 10 to the 19 all over 1.2 times 10 to the negative 3. So I'm going to treat these 10s, I'm just going to treat them with the same exponent rules we were using over there. So I don't like my negative exponents. I'm going to take this and move it up top. I'm going to 3.6 times 10 to the 22. I'm going to skip a step over, I skip the 1.2 over here, right? And then I think from here you would just do 3.6 divided by 1.2, which is 3. So it's equal to 3.0 times 10 to the 22. 3.0 times 10 to the 22.
Can I just write 3?
No, do it 0.0. So here's the general rule. Whatever I start with, so I started with 1 trailing decimal. That's what you should end with.
Okay.
So if you study science in college, you'll learn more about that. Sig figs, have you guys talked about sig figs in like chemistry or something? You ever talk about sig figs? Okay. Don't worry about it. Pretend I never said it. All right, 8D. We got 1.5 times 10 to the 6th times 7.6 times 10 to the 9. Okay? Someone help me out. Grab my calculator actually. Someone help me out. What's 1.5 times 7.6? 11.4, right? 11.4. Okay, and then I add my exponents on the 10s. Get 10 to the 15. Right? What's wrong here? What's wrong with this? Why am I not done? Yes, so this number right here is greater than 10. Right? Scientific notation, the number out front is between 0 and 10. So I gotta take this decimal and I gotta move it where? I need to move it over 1, right? I need to move it over 1. When I do that, this ups this exponent by 1 to 60. Right? Because now to get the original number back, I gotta move it over to the right an extra decimal place. So that's why that gets up. Is that really confusing? Okay, good, okay, good. And then E, oh, E's fine. E, 1.5 times 10 to the 13 and 8.5 times 10 to the negative 4 all over 1.2 times 10 to the 7. Okay, this looks scary. This looks scary at first. What I recommend is just simplifying the top and then simplifying the bottom. Okay, so let's simplify the top. 1.5 times 8.5. What was that? Someone get it? 12.6? 12.65 or 12.6?
12.75.
12.75, thank you. And then add the exponents, 10 to the 9. Okay, these two exponents get subtracted. 12.75 divided by 1.2. 10.625. Oh my gosh. Times 10 squared. And then this needs to be less than 10, so I'm going to move the decimal place over to the left. This gets up by 1. Final answer. Is that confusing anyone? Okay, I'm going to go ahead. Do for homework over the weekend. I got to post this on Schoology. Do everything under the P1 section. Everything under P1. Weekend, I'll take a few questions over tomorrow. Email me if you're confused. Sorry. You can email me tomorrow. You can do homework on Saturday. Everything under P1. No, we just did the notes P1, right? I did the wrong thing. What? Okay, no, so that's notes we just did. The homework I just gave you to P1. P1 for Monday. Yeah. Sorry, say that one more time. Like home or right here. I went down right in the musicians class. We had 2 1-minute class now, so yeah. I'm gonna know your budget. That's like for. I think it is good for mental health to like put screens and audio away too. So P1 homework due Monday. Have a good weekend, guys. Yeah, you take care.